Welcome. This is type of loads, last part 4. UVL represented by a trapezium. If you remember, part 1 was for concentrated loads, part 2 for UDL, part 3 for UVL represented by a triangle, 3 cases, right angle triangle, then isosceles triangle and triangle in general. Part 4, uniformly varying load represented by a trapezium. See, like this. To understand and to firmly get grip, I will take 2 cases. Actually, both are same case. Still, I am writing everything right now because later space is not there. What all I tell now, you should write at that time. See, case 1, first general statement, bookwork type. Remember, loaded length L0. Case 1 and later case 2 also, loaded length L0. Load starts from A to B. There also A to B. Now, linearly increases from left to right or from right to left, linearly decreases. Here, left to right linearly decreases, right to left linearly increases. Here, W1 per unit length, W2 per unit length. There is no space to write. Usually I never write U. I write per unit length. That I write next time. Now, make a note later. W1 is the minimum intensity. W2 is the maximum intensity. Here, W1 is the maximum intensity. W2 minimum intensity. These two are the bookwork type. That is no numerical, general case. Now, for each of them, I'll give numerical example. See, case 1, for this case, numerical example. Instead of W1, 20 kN per meter, linearly increases to 38 kN per meter, loaded length of 5 meter. Random number I taken. Then, here, uniformly varying load from 90 kN per meter. This is case 2 numerical example. 90 kN per meter, linearly reduces to 48 kN per meter, or from that side increases. Loaded length 8 meter. Now, what we have to do today? For all the cases, we require 1, this I am telling from beginning, magnitude of total load. Okay. 2, direction, downwards. Why waste time? 3, where is line of action of the total load? And 4th one, most important, moment of the total load about left extreme ends of the loaded length, that is A and B, everywhere, A and B, A and B, A and B. And also 2 points which are outside. Here, C and D, let it be X1, X2. Here also, X1, X2. Here, numerically, I decided 1.9, 1.6. See, no round numbers. 3.2 and 2.8. These all you require. Now, for each of this one, there are 2 solutions. So this class is going to be lengthy class. 2 solution, because trapezium you can maintain as it is. There is no problem. Expressions are there. But some people, they find difficulty. What are majority of places I have seen, they don't consider trapezium. What they will do is, they will divide this trapezium into a rectangle and a triangle, right angle triangle. A rectangle means UDL, you should know it. So see, they will divide like this. So you get one rectangle here, one triangle where right side, it is increasing to right side. Here, a rectangle and triangle, see, from left side decreasing to 0. Here also same thing. 20 here, 38 here. See, one rectangle, one triangle, rectangle, triangle. Whether you do directly as a trapezium or split into parts, answer is going to come same. Now, for bookworks, there is no answer, expressions only. For these 2 numericals, what I did is, I set the question. See, somewhere in the corner, I made it. You cannot see by camera because why? Somewhere up here, camera ends here. Maybe you can see the 3.2, etc. I made a note because I forget always. I made a note here. 1.9, 5, 1.6, 20, 38, 3.2, 2.8, 8, 90 to 48. Okay, sufficient for me. Now, later, once we will consider trapezium as it is for both the numericals, you will get the answer. I am not giving answer. You take your calculator and get it. Then I split into parts. Again I write expression. You should calculate the answer. Both should tally. Now, what I will do is, I wrote the answer in the beginning only. See, later I will tell you, answer already given. See, make a note. For this numerical example of case 1, total load is 145 kilonewton, down. For the total load, moment about A is 400, moment about B is 325, moment about C is 675.5, moment about D is 557, moment about C and A are clockwise, everywhere same. Moment about B and D are anti-clockwise, over. Same way for this question, I am rubbing the board now. For this question, total load is 552 kilonewtons. This I have to explain. And later, when you take moment about A is 1984 kilonewton meter. Moment about B, 2432, 1984 clockwise, 2432 anti-clockwise. Then, that I am writing once again there. Moment about C is 3750.4, about this point. Moment about D is 3977.6. So later I will tell you, you calculate and check the answer. If this class is thoroughly understood, then unknowingly you are covering UDL and also UVL represented by a triangle when you split, and the main part trapezium. So first we will cover trapezium, then alternate we will cover UDL and UVL represented by a right angle triangle. So everything ready. I will start one by one now. I will write case 1. I will put this sketch. Then I don't know. I may go to case 2 book work. I will finish. Order I will decide later. Or once I finish case 1, I may come to numerical of case 1. Case 2, numerical of case 2. Okay. Now, before you go further, I will tell one thing. In case you consider entire trapezium, this I told many times earlier, I cannot waste time each and every step there. I will tell last now. Area, if you want area, equal to sum of the two parallel sides divided by 2 into distance between the two parallel sides. So this full trapezium area is W1 plus W2 divided by 2 multiplied by L0. Same here also. This area 20 plus 38 divided by 2, then multiplied by 5. Here 90 plus 48 divided by 2 multiplied by 8. I will not explain once again. And suppose you want to locate centroid. See, I will write now only. See, I am telling for entire trapezium. Suppose you split into UDL, UVL, then trapezium will not come. See, CG, here more intensity, less intensity. See, centroid will slightly shift that side, maybe here, centroid. Here, centroid will slightly shift this side. Centroid will slightly shift this side. Centroid will shift this side. Okay, now, you want what is this distance and this distance. What is this distance and this distance. I won't write here because later I am writing this distance and this distance. What is this distance and this distance. I will tell last time. If you want to locate centroid for a trapezium, I am telling trapezium, first you decide it is always located along the loaded length, this way. See, there are two parallel sides are there. They are intensity of loads, this way. When you want to measure this way distance, measurement is from this side. You first decide whether you want from left side or right side. Okay, now, suppose you want from left side here, see, this distance, or if you want from right side, this distance, same everywhere. The expression for centroid is, once you decide from which parallel side you want centroid, the distance to centroid from that parallel side will be that parallel side. See, I told you, that parallel side plus twice of other parallel side divided by sum of parallel sides multiplied by distance between the two parallel sides. Distance between the two parallel sides divided by 3. For area it is 2. This all I told earlier, not once. Still I am telling. Okay, now for this one, I will not explain later. If I want this distance, W1 plus twice of W2 divided by W1 plus W2 into L0 by 3. Same thing here also. Here, 20 plus, if you want from this side, see, from this side, W2 plus twice of W1 divided by W2 plus W1 into L0 by 3, same here. From here, if you want, 20 plus twice of 38 divided by 20 plus 38 into 5 by 3. From here, 38 plus twice of 20 divided by 38 plus 20 into 5 by 3. From here, 90 plus twice of 48 divided by 90 plus 48 into 8 by 3. Or if you want from here, 48 plus twice of 90 divided by 48 plus 90 into 8 by 3. So when I explain further step, I won't waste my energy and voice. It is already told not once, many times earlier. Then one critical class, I put summary full board and I explain now. And when I go to cases now, I will again tell, see, once again I'll write W1 plus 2W2, etc. But don't expect me every time to tell, if you want from this side how to find this distance, or if you want from here how to find. Every time don't expect. If still you got difficulty, means you better not study trapezium. You divide into rectangle and triangle. That option is there. Okay, now I will start one by one case. Okay, we will continue. Actually, I adjusted the writing so that time consumed is lesser and I have to write lesser. But you should write everything every time. Do not write what way I write. Means I will come back once again here and change this one. But you should write once again. See, start. Case 1, right here. Case 1 in the general form. I already told W1 here, W2 here, loaded length L0, X1, X2 I told. Okay, now I won't waste time. Magnitude of total load for entire loaded length of L0 equal to area of the trapezium W1 plus W2 by 2 into L0 down. Next time onwards I won't waste time. And line of action of the total load from A, there is no space to write here. See, I will call XA bar. See, X bar from A. X bar from A equal to, from here, W1 plus twice of W2 divided by W1 plus W2 into L0 divided by 3, or from B, W2 plus twice of W1 divided by W2 plus W1 into L0 by 3. These all told so many times. Right. Now, moment of the total load, whatever you got for a loaded length of L0 about A is the total load, I written here, see, W1 plus W2 by 2 into L0 total load into this distance. Just now I explained that much clockwise. Okay, now, moment about B. You have to write once again below, not do this way. Equal to total load once again same, moment about B. So from here, W2 plus twice of W1 divided by W2 plus W1 into L0 by 3 anti-clockwise. This is all told. Okay, next. Moment about C. I'll give one more space here, equal to W1 plus W2 divided by 2 into L0 is the total load into X1 into moment into X1 plus further here to here. Don't write XA bar. Don't see here. Into this distance. That is W1 plus twice of W2 divided by W1 plus W2 into L0 by 3. That moment will be clockwise. Next, moment about D. I will do one thing. Okay, start. Total load, once again same, into from here, X2 plus this distance, that is W2 plus twice of W1 divided by W2 plus W1 into L0 by 3, it is anti-clockwise. Okay, this book work is over. Now write, alternately class. There is no space to write here. In the notes I will write. Class means first some important information. This will come now 4 times. You have to write every time same class. Some people find difficulty for trapezium. Maybe area there is no problem, but they get confusion about centroid. Full confusion. Such people need not worry. What you can do is the trapezium can be divided into a rectangle and a triangle. So as shown below, see, base L0, W1, W2. Here W2 is more than W1. This is the case of W2 more than W1 this way. So see here, light line divide. So you get a rectangle of W1. See here, W1. This remaining is, see this full is W2. This is W1. Remaining is W2 minus W1 per U. U means per unit length. There is no space to write here. Per unit length, per unit length. Now make a note. This rectangle is actually UDL. You should know it. You can maintain rectangle, but you are happy if it is UDL. Okay, now therefore, see here. There is a UDL of W1 per unit length for L0 length. Then uniformly varying load. See, do one thing. When you put arrow mark here, see, stagger it here. Do not write this way. See, it looks not neat. By staggering, what happens? See, if you stagger like brickworks, see, it becomes more clear. So stagger that way. So now, uniformly varying load of 0 here to W2 minus W1 per unit length there. Now, there is no space to write. See, W1 is magnitude of total load considering UDL. Everything is for entire loaded length L0. So, capital, not small w, this is capital W. See, capital W1 is magnitude of the total load for UDL equal to W1 into L0. This I should not tell. For UDL, intensity into loaded length acting at center L0 by 2 here, written, which will be at L0 by 2 from A or B. W2, capital W2, is magnitude of UVL, you can write represented by a right angle triangle, is given by area. I forgot here. You can write one note here. Given by area. Every time write here. Given by area. Area equal to half into L0 into W2 minus W1. Okay. Down. Line of action of which will be from here 2/3 L0, from there 1/3 L0. Okay. Now, this is a common now, from up now come here. moment of the total load for entire loaded length of L0, you write here, we are going to divide into two parts when you take moment of UDL and UVL, we will take separately and both will be same direction. Either, see, when you take this side, clockwise, no plus minus sign. You add those two, then decide clockwise, anti-clockwise. Start. Moment about A equal to, start here. Moment about A. See, I written A here, I know, forgot. A, this is B, this is C, this is D. Okay, see, about A. This total load, W1 into L0. W1 into L0 is the total load multiplied by L0 by 2. That is clockwise plus moment of this load first. Half into L0 into half into L0 into W2 minus W1 is the total load multiplied by, from here to line of action is 2 by 3 of L0. This also clockwise. Add those two, you get the moment. Okay, now moment about B. Moment about B. I will explain here. See, about B. W1 into L0 is the total load into L0 by 2 anti-clockwise. Half into L0 into W2 minus W1 into 1/3 of L0. That also anti-clockwise. I wrote here. Now 1/3 over. Next. Everything actually this you have to write below. Below you have to write here. Moment about C. Start. About C. First, this load. W1 into L0, total load, into line of action is here, x1 plus L0 by 2, x1 plus L0 by 2 clockwise, plus half into L0 into W2 minus W1 into x1 plus, from here to here is 2 by 3 of L0. That also clockwise. Add it. Lastly, moment about D. About D. Once again, same thing. This load into this distance, this load into this distance. Both are anti-clockwise. I need not waste time now. x2 plus L0 by 2, x2 plus, if someone tells not explain, then I am not the person to learn for you. Okay, x0. This, both are anti-clockwise. Anti-clockwise, anti-clockwise. Now, case 1, bookwork type over. Numerical, I will do second round because since it is already bookwork, I will do second bookwork. What I will do? I will put W1 more, W2 lesser. So, the triangle will come this way now. Let me finish that one. Then I will go both the numericals. Okay, I will prepare for that one. I won't explain much. I will write and briefly explain. Now, say case 2 bookwork. Then I will go to numericals because easy for IIT later. Case 2. W1 to W2 linearly reducing. That is, W1 is maximum, W2 minimum. Actually, there is no two cases, just to understand, because second time, see, triangle will come this way. Start. Magnitude, same as last time. Sum of the two, sorry, I should not tell. Line of action also distance same, but CG will centroid will be slightly this side. See, slightly this side. Okay. Then, moment about A. This total load into this distance I already wrote earlier. Moment about A over moment about B. Here, this is B. This is B, this is A. about B. Same load into, from here, W2 plus twice of W1 divided by W2 plus W1 into L0 by 3 anticlockwise. Moment about C. Total load into W1 plus 2W2. Moment about C. Okay. Sorry, moment about C means first what? First X1 plus W1 plus 2W2 divided by W1 plus W2 into L0 by 3 clockwise. Moment about D. Total load into, from here, X2 plus this distance, already explained, anticlockwise. This is bookwork type. Everything is told so many times, nobody can tell not clear. Now, alternately, class, same as what I told last time, write it here. This trapezium will replace by a rectangle and triangle. See, stagger here. Now, W1 is more, so triangle comes this side. See, this is W2. Oh, see, this is W2, not W1 now. This is W2 per unit length. Be careful. See, last time this was W1, W2. This is W1 minus W2. So here, this will become, I already wrote it here. This is W1 minus W2 per unit length. This is not W1, it is W2 per unit length. Why? See here, W2, why? This way. Okay, now, W2 magnitude, this magnitude equal to, oh, I last time wrote W into L0. I forgot last time, I don't know why it happened. Last time, see, last time this UDL was W1, but the moment I had taken correctly, I forgot write suffix 1. Make a note, it is not W. Last time it was, see, this was W1, make a note. Now it is W2, there is no W here first of all. W2 into L0 acting at L0 by 2, L0 by 2. This total load, half into L0 into W1 minus W2. Not W2 minus W1 now. W1 minus W2. And line of action is, see, last time it was this way. From here 2/3, from there 1/3. Now, from here 1/3, I written here, and from there 2/3. This is already known for you. Okay, start. Now come here. Come here. Moment of the total load about D equal to, right there, one note. When you want a moment, we will consider moment of UDL and UVL separately and add them. Either both are clockwise or both are anti-clockwise. Any mistake is there? W2 into L0, W1 minus W2. Oh, correct. Everything correct. Okay, start. Moment about this point. W2 into L0 is the UDL. See, W2 into L0 is the UDL into L0 by 2, clockwise. Don't worry about the gap. Don't worry about the gap. This is clockwise, plus one more. Half into L0 into W1 minus W2. See, this is the load, this is the total load, into from here, X, about A, 1/3 of L0. That also clockwise. Over. Don't worry about space. Space I am adjusting. Okay, over. Moment about A over. Now, moment about B. This load into this distance. Oh, same. But it is anti-clockwise. But this load into this distance, not 1/3, it is 2/3 of L0. See, this load into L naught by 2, this load into 2 by 3 L naught. Both are anticlockwise. Anticlockwise, over. Next. Oh, sorry, I forgot. Moment about, see, I forgot to remove last time. I first wrote moment about, see, such, it is not a mistake actually. I told just now, moment about A. The D I forgot to remove. No one should complain. You wrote about, forgot to rub out. The previous part you write A. That is what I told earlier. Now, just now, I finished B. Now, moment about C. But I'm dictating it here. Moment about C. This load into this distance is x1 plus L naught by 2 plus half into L naught into W1 minus W2 into x1 plus 1 by 3 of L naught. Both are clockwise. You see how much effort I am putting for such an effort. Some small, this is not technical mistake, forgetting, right? Okay, this is also over. Lastly, moment about D. Start. About D. This load into x2 plus L naught by 2, anticlockwise. This load into x2 plus 2/3 of L naught, anticlockwise, over. With this one, book work is over. Now we are going for a numerical. Fresh sketch I am writing. This I am not writing. Numerical, actually numerical is more important. Book work will make your concept clear. Numerical will help you for problems. Okay, now we will go for 2 numerical examples. Start now. Now numerical. I need not explain how much I explained earlier, because when book work is clear, numerical should be more clear. Still, I told question, I noted down somewhere there. At A, 20 kN per meter linearly increases to 38. Okay, start. Now, put the sketch. First you write the sketch. Then second time write. Therefore, see, CG will be somewhere here. First you consider the entire trapezium. This is magnitude of the total load for entire loaded length of 5 meter. 20 plus 38 divided by 2 into 5. That is, slightly shifted here. Okay, no problem. Not a big issue. Okay. Now, okay. I told total load is given by area of the trapezium. Now, if I tell further, some will feel bored. Okay, over. Line of action of which from here, let it be XA bar. From here, let it be XB bar. XA bar equal to 20 plus twice of 38 divided by 20 plus 38 into 5 by 3. I wrote here. XB bar from B, 38 plus twice of 20 divided by 38 plus 20 into 1/3 of 5. Okay, over. Now, I wrote everything now. Now, moment of this total load about A. See, first total load. 20 plus 38 divided by 2 into 5 is the total load into this distance is 20 plus twice of 38 divided by 20 plus 38 into 5 by 3 kilonewton meter clockwise. Now, moment about B. Total load same, but distance is now changing from here. 38 plus twice of 20 divided by 38 plus 20 into 5 by 3 kilonewton meter anti-clockwise. Okay, about B over. Now, moment about C. Anti-clockwise, moment about C. This total load, once again same, into from here 1.9. 1.9 is from C up to A. Then from A up to load is this centroid distance, that is plus 20 plus twice of 38 divided by 20 plus 38 into 5 by 3 kilonewton meter clockwise. Lastly, moment about D. The total load into 1.6 plus here to here is the ink I have to put now, it is not writing properly. 38 plus twice of 20 divided by 38 plus 20 into 5 by 3 kilonewton meter, that is anti-clockwise. Okay. Now over. Alternately, I told earlier, right in the class, see, that is those who find difficulty for trapezium. 20 kN per meter at A to B, 5 meter. 20 to 38 kN per meter. What you do is, see, divide into rectangle and triangle. So rectangle will be 20 kN per meter. That extra triangle will be 18. How you got 18? This is 38, this is 20, see here, this will be 38 minus 20, you got 18 kN per meter. And remember, this rectangle is nothing but UDL. UDL. Now, put a neat sketch. First put UDL of, instead of rectangle, UDL is better. UDL of 20 kilonewton per meter. Okay. Or you can write rectangle also, no problem. Then over that one or above that one, uniformly varying load of 18. Same. Now see, W1, magnitude of only UDL, 20 into 5 kilonewton, acting at 5 by 2 from here or 5 by 2 from there. I wrote it. W2, total load magnitude for UVL represented by triangle, half into 5 into 18, line of action, 2/3 of 5 from here or 1/3 of 5 from there. Okay. Everything written here. Now, next, continue. Moment about A equal to, see now be careful, I think I have to put some ink. Okay, I'll try some other pen. It is working. Let me see. Equal to, see, moment about A. This UDL first. 20 kilonewton per meter for 5 meter total load. See, 20 into 5 is the load into 5 by 2 into 5 by 2. Don't worry about the gap. Clockwise plus half into 5 into 18, half into 5 into 18 is the total load into from A 2 by 3 of 5. 2 by 3 of 5 kilonewton meter. This is also clockwise. Clockwise. Answer is in kilonewton meter. Both are clockwise. Over. That is moment about A. Now, moment about B. I will first write. You should not do this way. You should write once again. (20 into 5 is the total UDL into 5 by 2 anti-clockwise, and half into 5 into 18 is the total load here into 1 by 3 of 5 anti-clockwise. Over. See, these all, someone will tell, sir, why are you telling this way again and again? Yes, perfection you require. Moment about C. Start. Don't do this way, you write once again. Moment about C. See. 20 into 5 is the total load into 1.9 plus half of 5 plus this total load. Half into 5 into 18 into 1.9 plus 2 by 3 of 5. Both are clockwise. Both are clockwise. Over. Lastly, moment about D. See here. 20 into 5 is the total load into 1.6 plus 5 by 2 anti-clockwise. Half into 5 into 18 is total load into 1.6 plus 1 by 3 of 5 anti-clockwise. Okay, now do one thing. Just now earlier we found moment based on full trapezium, and now you found based on two separate loading. You calculate that answer, calculate this answer, both will come same answer. I already told earlier in the beginning of the class. I told. Now see, what I will do is so much of explanation. Now last case is numerical, that is 90 here, and here how much? 48, this way. If someone will tell, sir, this also you explain, means it is insulting, not for me, for those who will tell. So this I will do one thing. Briefly I will explain, I will dictate. Writing I will not do. You should practice, like yesterday's class, last class. Last case, I will somewhere here, right here, big sketch. Then I will dictate. Answer already given. How we found here, same way find. You should make a fair copy of each and everything systematically. Then only the full grip will come. I will prepare for that one. Now lastly, numerical for case 2. I will dictate, you should write, because so much explained earlier. See, 90 to 48. First write the sketch, don't touch it. This all you write first, A, B, C, D. Then second time write. Resultant load will pass here. Considering full trapezium, you write here. If you consider the full trapezium, magnitude of the total load equal to 90 plus, you should write 48 divided by 2 into how much? Into 8. Loaded length 8. That much kilonewton down. Now, suppose you want this distance. That will be from here. 90 plus twice of 48 divided by 90 plus 48 into 8 by 3 meter from A, or if you want from here, this distance from here, 48 plus twice of 90 divided by 48 plus 90 into 8 by 3 meter from there. Okay. Now, first moment about A, this total load into this distance clockwise. Moment about B, this total load into this distance anti-clockwise. Moment about C, this total load into 3.2 plus this distance. Moment about D, the total load into 2.8, correct? Yes, 2.8 plus this distance. Answer already given earlier, calculate. Alternately, 90 to 48. See, divide. Then one rectangle of 48, a triangle of 42. How you got 42? If not clear, better not study structural engineering. Okay, this total is 90, this is 48. How I got 42? Okay, now this is nothing but UDL. So UDL of 48 kN per meter, varying load like this. Now, for this UDL, W1 I told, equal to 48 into 8 kilonewton down. For this UVL, W2, space is not there. Okay, I will remove that 8 meter. 8, go there. 8 meter, okay. from here to here is 1 by 3 of 8 meter. From here, where is the space here? Okay, I can mark here. Here to here will be 2 by 3 of 8 meter. Now, total magnitude equal to W1 plus W2. Moment about A. This load in, sorry, I forgot right here. This everybody knows the answer. 8 by 2, 8 by 2 meter. 8 by 2, 8 by 2. Okay. Moment about A. See, both are clockwise. This load into 8 by 2 meter. This load into 1 by 3 of 8. Both are clockwise. Moment about B. This load, it is there, 48 into 8 by 2 anti-clockwise. This load into 2/3 of 8 anti-clockwise. Moment about C. This load into 3.2 plus 8 by 2 plus this load into 3.2 plus 1/3 of 8. Moment about D. This load into 2.8 plus 8 by 2 plus this load into 2.8 plus 2/3 of 8 meters. You write everything, so much explanation given. You see how much I told first statement, explanation. You go through all the classes. People will tell, first of all, not required. We would have done ourselves only. Still, I want to complete. Answer given, check the answer. Now, next class, I will put title, most important class for types of loads. I will tell you reason later. Completely what you have done so far with the extra means how to find moment about an intermediate point that is required for strength of materials and structure analysis. So next class will be a marathon class. What all we have done so far, I will briefly tell. I will not waste time. I will concentrate on the additional part. You first go through all these classes and there, when I tell already over means refer the previous class and make fair copy. Which is already not over, I will systematically explain. Okay, we will meet in the next class. Thank you.